In a world that is rapidly changing, where new technologies, environmental crises, and societal challenges continuously shape our future, how we think about science, knowledge, and creativity must evolve. Enter radical science, a groundbreaking approach that blends scientific inquiry, artistic expression, and technological innovation to solve global problems in bold, interdisciplinary ways. But what exactly is radical science, and how does it differ from traditional science? This article explores the concept of radical science and why it's becoming a crucial framework for understanding the complexities of our modern world. What is radical science? At its core, radical science represents a departure from traditional scientific methods that typically segregate art, technology, and science into separate spheres. Radical science integrates these disciplines, encouraging collaboration between scientists, artists, engineers, and philosophers. It challenges the conventional belief that scientific knowledge can only be acquired through rigid, empirical, and narrowly focused methods. This interdisciplinary fusion allows for new ways of thinking and problem-solving. For example, artists can use their creative abilities to visualize abstract scientific data or represent complex systems that are otherwise difficult to understand. Meanwhile, scientists and technologists may approach artistic practices to inspire innovative technological solutions or ethical reflections. Together, they create solutions that transcend the limitations of individual disciplines. Radical science builds upon the growing movement that blends speculative design, creative coding, and bioengineering. These fields don't just seek to understand the world. They aim to reshape it, offering visions of alternative futures, systems, and societies. Why is radical science necessary? So, why do we need radical science now? The world faces an array of urgent challenges: climate change, technological ethics, geopolitical instability, and even the future of humanity itself. Traditional approaches to these problems have often been slow or inadequate, failing to address the deep interconnections between ecological, technological, and social systems. Radical science offers a more holistic perspective, urging us to think beyond siloed knowledge and embrace diverse methods of inquiry. The interdisciplinary nature of radical science allows for the flexibility required to tackle these complex issues. Problems like climate change, for example, involve not just environmental science, but also technology, economics, politics, and human behavior. Radical science encourages cooperation across fields, making it possible to approach such issues in innovative and more effective ways. Additionally, as technology rapidly advances, such as the rise of artificial intelligence, genetic engineering, and space exploration, the need for forward-thinking scientific models becomes even more pressing. Radical science pushes us to imagine and explore futures that are not only scientifically plausible, but also ethically responsible, socially just, and environmentally sustainable. The role of speculative thinking. One key feature of radical science is speculative thinking, the ability to imagine alternative worlds and futures that may not yet exist. Speculative thinking allows scientists and artists to explore what is possible, even if it's not immediately probable. It is in this space of imaginative potential that new scientific innovations, solutions to pressing global challenges, and even ethical frameworks are often born. Take, for example, speculative design, a field where designers create hypothetical models of future technologies, environments, or societies. Speculative design doesn't just predict the future. It imagines it, pushes the boundaries of what's possible, and provides a tangible vehicle for future discussion and action. Through this creative approach, radical science encourages people to question the status quo and reconsider the paths humanity might take as technology and society evolve. Radical science in action. Key examples. Radical science is not just a theoretical concept. It is already in action in various groundbreaking projects. For instance, some artists are using bioengineering techniques to design new life forms or ecosystems, blending the boundaries between nature, art, and technology. Digital art projects that visualize climate change, data flow, or quantum mechanics are not only aesthetically impressive, but they also communicate complex scientific ideas to broader audiences. These projects are not mere abstractions. They reflect a desire to rethink the relationship between human society and the environment. In speculative design, artists and designers often team up with scientists to develop futuristic solutions for issues like sustainability, food security, and bioengineering. By working together, they propose new forms of life, new technologies, and new approaches to how we might live more harmoniously with the planet. For example, some speculative designs consider how cities could integrate nature, while others focus on creating new forms of energy that do not harm the environment. Additionally, synthetic biology projects, which involve engineering new organisms or modifying existing ones, often involve both scientific rigor and artistic creativity. By experimenting with biological systems, artists and scientists can ask, what if? Imagining new possibilities for life, medicine, and environmental conservation. A call for collaboration and creativity. The rise of radical science signals the need for greater collaboration between traditionally separate fields. Scientists, artists, and technologists must learn from one another, inspire each other, and co-create solutions that address the most pressing issues of our time. Radical science is an invitation to expand our boundaries of knowledge and rethink how we engage with the world. By combining creativity and empirical inquiry, we can uncover novel solutions to problems, predict new scenarios, and create more sustainable, ethical futures. It's a shift from seeing science as a solitary, academic pursuit to recognizing it as an ongoing, interdisciplinary conversation that is deeply connected to human culture, values, and aspirations. Looking forward, the future of radical science is full of promise. As artists, scientists, and technologists continue to work together, the boundaries between these disciplines will blur even more, creating a fertile ground for new ideas, innovations, and discoveries. By fostering creativity, speculative thinking, and interdisciplinary collaboration, radical science can offer us the tools to better understand and ultimately change the world we live in. In the coming articles, we will explore how specific fields within radical science, such as bioengineering, speculative design, and technological intervention, are already having a tangible impact. We'll also dive into the ethical considerations, challenges, and opportunities that arise from this innovative approach. Radical science may very well hold the key to a more sustainable, imaginative, and resilient future.